We want to continue with our definitions for exponents to include exponents that are rational numbers. Up here I've written the definition for some base a raised to the 1 over n power, where n's an integer. That turns out to be, by definition, the nth root of a. Now we want to make sure that if we have any square roots here that we don't have negative numbers under the radical. So we'll just say for this definition works for anything that's like this that's defined to be a real number. We're going to leave out complex numbers for the time being. So a to the 1 over n is defined to be the nth root of a. So 9 to the 1/2, well, that should be easy. Square root of 9, which is 3. 8 to the 1/3 power, I use my definition, cube root of 8, that comes out to be 2. So fractional exponents like this, exponents that are rational numbers, 1 over 2, 1 over 3, they stand for the second root and third root of whatever number there was for the base. Now I want to change this a little bit and allow the numerator to be something other than 1. So if I have a to the m over n, that's going to be either the nth root of a to the m or the nth root of a all raised to the m. This just means that we can do this in either order. We can take a to the m first and take the nth root of that, or we can take the nth root of a first and raise all that to the m power. And again, we're going to leave out even roots of negative numbers so that anything we have under here like this represents a real number. Okay, so if I have 8 to the 2/3 power, what you want to notice is that the denominator here stands for the root and the numerator stands for the power, a to the m power. So 8 to the 2/3, that's going to be the cube root of 8 quantity squared. So I can write it like this if I want. Cube root of 8 quantity squared, that will be 2 squared, which will be 4. So 8 to the 2/3 power, the third root of 8 is 2, squared is 4. So it makes sense that it comes out that way. And again, this is a definition. 9 to the 3/2. Well, if I think of this as being the root and this being the power, I'll take this base, 9. I'll take the second root, which is the square root, positive square root of 9, which is 3. I'll cube that. I get 3 times 3 times 3, 27. So once you become familiar with this definition for rational exponents, it becomes pretty easy to work problems like this. That's the root, that's the power. All right, what about if I have 25 to the negative 3/2? Well, 2 is the root, 3 is the power, and the negative sign, remember, stands for the reciprocal. So if I was to write this out, I would say, well, this is 1 over 25 to the 3/2. I could take care of that negative sign first. Then the second root of 25 is 5. Cubed is going to be 5 times 5 times 5, or 125. So I can get pretty complicated here with these exponents and still have a nice way of simplifying these things. Second root of 25 is 5. Cubed is 125, the reciprocal of which is 1 over 125. So there we have a look at the definitions for many different kinds of exponents. Positive integer, 0, negative integer, and then rational exponents.